So here is section 2.4. This is the last section in the unit. We're getting ready for a test. The test will be next week. We have all about limits at infinity, limits that go to infinity or involve infinity. And so we're going to be looking at it horizontally and we're going to be looking at it vertically. And if you watched the video, hopefully you did, the horizontal asymptotes, I call them HAs because I abbreviated HA, and vertical asymptotes are VAs. And so there's three things that he real quick went through about qualities or characteristics of horizontal asymptotes versus vertical asymptotes. So if you are a horizontal asymptote, you look like this. It's a line that the graph approaches but rarely touches. In this case, horizontal asymptotes can cross. We kind of talked about that when I first talked about asymptotes with you. So you can cross a horizontal asymptote. You cannot cross a vertical asymptote. You never, ever, ever will cross one of those. So in this case, you can cross it. Here's a picture that he gave you for one of the examples where it crosses over. It keeps bobbing and weaving across the x-axis. So what you're looking at is what it's doing on the far left when you go far left on the graph versus what are you doing when you go far right on the graph. So this is the left end behavior, the LEB, left end behavior. What's it doing on the left? This is the right end behavior. What's it doing when you get to the right? What's it doing when you get to negative infinity? And what's it doing when you get to positive infinity? So it shows the end behavior of the graph, and you can have more than one horizontal asymptote. We're going to see some examples of that today. Also, while I'm kind of chatting through this, you're going to need Desmos. So you want to pull up your Desmos also on your Chromebooks. If you have a vertical asymptotes look like this. Vertical lines that the graph approaches and never touches. You can never cross a vertical asymptote. So it comes real close. It's like getting to a dead-end street. Come to the end of the street, well, get into an intersection where you have to either go right or left. You get to the end of the road, you either have to go left or you've got to go right from this thing. Same thing goes with vertical asymptotes. You can't cross them. You got to go left or right or up or down in our case. So the graph goes either to positive infinity or negative infinity. You come up to the line, you've only got two options. You're either going up or you're going down. Positive infinity, negative infinity. You can have more than one for these also, just like the horizontals. So he went real fast through those explanations, and then he took some time talking about horizontal asymptotes, HAs. If I look at the left end behavior, what it's doing far to the left, that means I'm concerned about the x values that are close to negative infinity. So the limit as x approaches negative infinity for the function is looking at the left side. What are the y values doing? What are they approaching? Remember, with limits, it doesn't have to equal that y value. It's what it's approaching. All right, so here's some examples he gave you. He gave you some pictures of different ones with horizontal asymptotes. There you go. If you're looking at the right end behavior, that's if your x values are far to the right, like going towards positive infinity. So you would have the right side of the graph, you're looking at what the y values approach. And so he went through all that explanation, and then he came down here and he said, all right, now use your calculator and find these asymptotes. Now we're going to use Desmos to do this because he was using a graphing calculator and we don't have access to those at the moment, but we do have access to Desmos. So I'm going to show you real quick how to do this. If you pull up your Desmos, I'm going to share my screen and I'm going to pull up Desmos as well, and we're going to actually graph some of these functions to see where these asymptotes are going to be. So let me share my screen for Desmos. And again, stop me and put it in the chat if you need to ask me a question. So here's the first one. You see it here. I have it graphed in already. I'll give you a second if you want to put yours in. You always want to, when you're dealing with fractions, you want to make sure that you put parentheses around the top and parentheses around the bottom. So the function was 3x minus 4 and x plus 1. And again, he had the calculator that he used to do it, and he was kind of quick going through showing you different ways to do it. We're just going to do it as simply as we can with Desmos. So I have my first one in here highlighted. I'm going to go to the edit list at the top here and go to the table. And remember, I'm looking for what it's doing when I go way far to the left. Well, way far to the left is negative infinity. And I can't put negative infinity on my table because negative infinity isn't a specific number that it's going to give me a corresponding y out. So what I'm going to do is put in a negative, and then I'm going to put a 1 and just start putting zeros in. And look at what it's doing. The more zeros I put in, going towards negative infinity, the closer this gets to 3. Well, that's where your horizontal asymptote is on the left. The left end behavior goes to 3. I'm going to show you how to write this in just a second. But we also want to know what it's doing far to the right. So I know if I trace this far to the left, I'm going to get a y value that approaches 3. If I go far to the right, that's a positive infinity type number. So I might be at 10, I'm going to keep adding zeros at 100, at 1,000, keep adding zeros. Oh my goodness, look, my number is getting closer to 3. Remember, it's not what it has to equal, it's what it's approaching. It doesn't have to necessarily equal 3. So if I go far to the left, I get 3. If I go far to the right, I get 3. That means that the horizontal asymptote is 3. And so, let me take you back here to the notes. And if you look, this one here, the limit as x approaches infinity, you get a value of 3. The limit as x approaches negative infinity gives you a value of 3. Therefore, your horizontal asymptote's at 3. So this bottom stuff here is what you want to write. This is what I was saying about the notation being important. You've really got to literally write the limit as x approaches infinity. This whole thing has to get written. And this whole thing with the limit as x approaches negative infinity of the function equals 3. And then the horizontal asymptote, horizontal lines are always y equals whatever the number is. All right, we could do the same thing now. These were kind of examples that he did. You can do the same thing. If I go to this graph, I'll show you on this paper first, and then I'll show you on Desmos in just a second. When I put in a really small number, I get 2/3. 2/3 is like 0.666 repeating, whatever that is. If I go towards a really big number, like infinity, I get 2/3. So my horizontal asymptote is at 2/3. For this last one, when I graph it and I go to the left, I get -4 for a really small number. And when I put in a really big number, I get 5. This one doesn't, it actually has 2 horizontal asymptotes. Let me say that on here. I have 2 horizontal asymptotes. One of them is at y equals -4, and one of them is at y equals 5. And so that's that last problem. Now I'm going to go back and show you the pictures of those real quick on the Desmos thing. And we'll verify that that's really the case. Okay, so let me share back. Take this guy away. This is the second one right here. All right, let's graph this guy. Actually, he is graphed, you just can't see him.
If you click the circle to the left of the equation, it'll show the lines.
Just click the circle. There it is. Thank you, I forgot to click it. You're right. I would have messed me all up. Thank you. All right, so I have the picture here. It's kind of a weird picture, but I'm going to go to the table again, and I want to put in what it's doing really far to the left. So I'm going to put in -1, and it does not matter what number you choose. You're just picking a really small number. I tend to do 1 and then a bunch of zeros. That gives me 0.6 repeating, like we said, 2/3. If I put in a really big number, I put in 1 with a bunch of zeros after it, gives me the same thing, 0.6 repeating, and that is my 2/3. So that's a verification for that particular one. And then the last one, to verify this guy, here's what he looks like. If I go to the table and I put in a really small number, -1, bunch of zeros, I get -4. If I put in a really big number, 1 and a bunch of zeros, I get 5. And those were those 2 horizontal asymptotes. So here's one that has 2 asymptotes that are horizontal. One's up here at 5 for the one part of the graph, and one's down here at -4 for the other part of the graph. And so that's all the stuff he talked about with horizontal asymptotes, and then he switched it up and talked about vertical asymptotes. So let me X out of this. Okay. If I go to these vertical asymptote things. So these are now where the limits, your answer for the limit is going to be infinity or negative infinity. Your answer is infinity or negative infinity. So for vertical asymptotes, and you're going to be approaching a particular number, you're going to come up to that number and then have to go towards negative infinity or have to go towards positive infinity. So for vertical asymptotes, this little number here, this little x approaches is going to be some kind of a number. And you're going to approach it from the left with the minus sign or from the right with the plus sign. We saw that in the last couple sections when we've been talking about limits. So what happens is you're going to have an answer. If I approach negative 2 in this case, the picture that they gave you, if I approach negative 2 from the left, I go to negative infinity. If I approach it from the right, I go towards positive infinity. My answers are going to be negative infinity or positive infinity. If I have, as I approach that number, answers of infinities, that tells me I have a vertical asymptote at that number. So the number in this case is x equals 2. Negative 2, right? Negative 2. Should be negative. So vertical asymptote, and vertical lines are always x equals, where horizontal lines are y equals. So horizontal asymptotes, y equals whatever the number is. And vertical asymptotes, it's x equals whatever the number is. And then he showed you how to do it from a table, finding the end behaviors. So they gave you an equation, and they said, okay, and he just picked random numbers. Now, as we've set up our charts, it doesn't matter what numbers you pick for your chart, but you want to be really close to the questionable area when you're setting up your numbers on your chart. So he went from the left, he went to negative infinity. Coming at it from the right, you went to positive infinity because you got infinities as answers. That's a vertical asymptote at x equals negative 3, this questionable place. And again, this was all on the video. He goes a lot slower. Last equation is this guy, same thing. Put it in your calculator. This gives you, this is talking about exponential, it's talking about scientific notation. So this would be like negative 3.8 times 10 to the 6th power. This is 3.8 times 10 to the 6th power. This is a really small number because it's negative. This is a really big number on this side. So really small numbers, negative infinity. Really big numbers, positive infinity. You have answers of infinity when you come close to 10. So therefore, there's a vertical asymptote at x equals 10. And that is the end of the video note stuff for this. You never have to do these skills review. That's just there for extra practice if you want it. All right, questions on any of that? All right, here's the random question. What is your favorite pie? Make sure you answer for attendance purposes. Don't like pie. Oh, I've never had sweet. Oh, yes, I have sweet potato. Hopefully we will be back in school for Pi Day. Kaylin, grandma's. I love it. Hopefully we'll be back in school for Pi Day. Funny enough, that was the last day of school before we were shut down, was us celebrating Pi Day in my classroom. So hopefully we can celebrate Pi Day and we'll bring pies in and have a good time. Sebastian's key lime also. Good stuff. Okay. All right. So here's some examples that I picked out that go with what we're talking about. There's going to be, you've got to use the same notation I'm using, okay? So this is going to be important. So it says to us, use limit notation to represent the horizontal and vertical asymptotes. Sketch them on your graph. So you're going to take, let's sketch them first. If I look at a vertical asymptote, well, vertical asymptote, I'm just going to draw them. The vertical asymptote that the line, you can see kind of where the line approaches, would be right about there, right through the middle. We usually draw them as dotted lines. And you can see there's also a horizontal line that this graph approaches. If I go this way, so I've drawn them. That's where I believe they look like they are. And now I have to use limit notation to be able to describe what they're doing. So limit notation, LIM, x approaches with an arrow, And if I'm talking horizontal asymptotes, horizontal goes this way. I want to know what's it doing way on the left and what's it doing way on the right. So if I'm way on the left, I'm going to negative infinity. What's that graph doing when I go really far to the left? And then I want to know what's it doing when I go really far to the right. Well, really far to the right is positive infinity. And here's my notation. I always, always, always have to have that same notation when I'm talking about horizontal asymptotes, and they're asking me to use limit notation. So let's talk about what it does. If I'm really far to the left, I'm tracing this really far to the left, what is the y value approaching? If I come over here, it looks like it approaches at -1. So it looks like if I keep going and tracing, it gets closer to that where I've drawn my line at -1. And if I go really far to the right towards infinity, it gets closer to this dashed line that's also at -1. And so I know that I have a horizontal asymptote. Horizontals are always y equals. And the number that they both approach is -1. So I have used limit notation to represent the horizontal asymptote. And then I'm ready to talk about the vertical asymptote for the picture. Well, that's this line. So what x value am I concerned about? I'm concerned about -1, -2, -3, about where -3 would be. So now I'm doing the limit notation would be the limit as x approaches that questionable place at -3 from the left for my function, and the limit as x approaches -3 from the right for my function. So my setup is always going to be limit notation. Just like this, the number is going to change though. It's the number where you think that vertical asymptote might be. So let's answer the question. If I go -3 from the left, I'm over here tracing it and I'm going towards positive infinity. That's my answer for this. If I'm going towards -3 from the right, I'm going towards positive infinity. I get answers of infinity, which verifies that I really do have a vertical asymptote. And my vertical asymptote is x equals whatever this number is that you have that you're approaching. So in our case, -3. So that's all the stuff you need to write for using limit notation to represent your horizontal and vertical asymptotes. I know it's a lot of writing, it's a lot of notation. Okay, next set. Also stop me or toss it in the chat if you have something you want to look at more deeply. Next one I want to look at, I picked out number 7 here, and it says use a graphing calculator, we're using Desmos, to find the horizontal asymptotes. Use limit notation to represent both the left and the right side and behavior. So in other words, it's saying to us, we're going to get to Desmos in just a second, but we want to know what's the limit horizontal asymptotes when I go far to the left, -infinity, for this function, and what happens when I go far to the right for this function. That would be going towards positive infinity. So that's my notation that I'm looking at, and I want to know what's it doing on either side there. So we're going to go to Desmos and we're going to graph it and see what the deal is. All right, so I'm going to share my screen again. I am going to show you my Desmos picture. And we are this guy. I'm going to turn him on. Now, I have it already plugged in, so you can just watch my screen. But when you go to do the practice problems on your own, you're going to want to put in these equations, whatever they might be. All right, so I've got it turned on. I see my graph. I kind of feel like there might be two different ones, right? Because if I'm thinking horizontal lines, it kind of has this guy up here that's going to be a horizontal asymptote, and this guy down here that's going to be a horizontal asymptote. So I have the feeling there might be two different ones. But let me put it in a table and check it out. So I need a number far to the left, like -1 and a bunch of zeros. Put in, oh look, it already 2'd on me. I've got a 2 when I go far to the left. Kind of makes sense if you look at the graph. If I go far to the right, now I'm putting in a big number, 1, 0, 0. Oh, it went right to 8. So I have two different ones. And again, I'm looking at the graph. Does that make sense? Here's 2, here's 8. Yeah, that makes a lot of sense. So if I go back to my notes here, I am plugging in. If I go far to the left, I got 2. And if I go far to the right, I got 8. And verifying from the graph, that means I really do have two horizontal asymptotes. One of them is at y equals, remember horizontal lines are y equals. One of them is at y equals 2. One of them is at y equals 8. Some of them will have 2, some of them might have 1. It just depends on how the graph goes. And you'll see that from your Desmos stuff. So the rest of that section is all done the same way. Number 10 is next on our list. Number 10 is this guy. This one says, fill in the table and use that information to identify the vertical asymptotes. Use limit notation to represent the behavior of the graph at the vertical asymptote. So the questionable place is this place right here, -2. They're telling me that they kind of give you the value of what you're looking for. They know that this, if I do a direct substitution, in other words, if I do a direct substitution into this, I'm going to have a 0 denominator, which means it's going to be undefined. So this is a place -2, and you'll see that when we get into the Desmos side of this in a second. The question is, though, what kind of numbers do you put on your chart? So if you follow kind of the same pattern that he did on the video, and you can even see it from the chart up above, he went a little bit to the right. He went like 1,000th away, and then 1/10 away, and then to the next number. And then he went, so in other words, like if I were to do the same type of thing, he, on this end, if I'm at -2 and I go 1 to the right, I'm now at -1. And if I go 1 to the left, I'm going to be at -3. So those are my outer pieces, right? And I can pick whatever numbers I want in between here, but probably these two that are directly next to it, I want to go really, really, really close, like 1,000th or so away. So if I'm looking at this guy over here, if I'm at -2 and I go just a smidge to the right of that, that's going to be 1.999 negative. Do you see how I'm 1,000th away to the right? And then this guy here is going to be negative, I don't know, let's make it 1.99. And then if I do the same thing over here, if I go 1,000th this way, that's -2.001. And this one would be -2.01 if I go 100th away. It doesn't matter what numbers you pick. It's totally your call. You just want to be really close on these two that are next to it. Okay? All right. So we are going to go to Desmos and see what this gives us. So let me switch back and take away this piece. I am looking for this 3x squared guy, this guy. Hang on. Okay. So this is a picture of this 3x squared minus 20x minus 7. You can see it on the screen there. And what we're concerned about now, we're going to go to the table and we're going to put in the values that we had on the table. So if I go to the table, and you can just kind of follow with me and copy in your table, we have -3. Gives me 3.333. We have -2.01. Oop, not 10, 2.01. That gives me 300. Interesting. 300.333. If I put in a -2.001, -2.001, that gives me 3,000.333. If I put in -2, because that would be the next thing that you come to, oops, -2, look at it, gives me undefined. Kind of interesting, right? That was what I was talking about or referring to with that 0 denominator thing. If I keep going, I've got negative 1.999, not 1990, 1.999. That gives me a negative 2999.7. If I put in negative 1.99, I get negative 299.7. And if I put in a negative 1, I get negative 2.67. Okay, so I'm going to take us away from that. I think you've seen us enough where we've seen those, how to use those tables. So if I look at my chart again here, right? If I look at the chart and fill this in, this guy in the middle was undefined, and all of these numbers came just from using the Desmos thing. I filled in the table, I need to identify where the vertical asymptote is, and I need to use my limit notation to represent the behavior at the vertical asymptote. So here I go. Here's my limit notation. LIM, X with an arrow, and then my questionable place, the place that I'm looking at, is what's it going on at negative 2. So it's going to be from negative 2 from the left of my function, and then the limit as X approaches negative 2 from the right with a little plus sign of my function. So from the chart, looking at it from the left is coming this way. From the left would be this way. What's happening to my numbers? They're getting bigger and bigger and bigger. They went from 300 to 3,000. They're getting bigger. This is positive infinity. They're getting bigger. If I come from the right, that's going this way, my numbers are getting more negative, which means they're getting smaller. They're going towards negative infinity. And because I have answers of infinity on either side of negative 2, it verifies that I really have a VA, vertical asymptote, at X equals negative 2. Vertical asymptotes are X's, horizontals are Y's. Okie doke, that takes us to pretty much our time. So your task, and let me show you back here. You're working on section 2.4, numbers 1 to 11, and it's going to be due by tomorrow, okay? So you're filling in the rest of the practice problems from 1 to 11, and you're going to send them or turn them into our Google Classroom page. Hopefully I won't delete them before you send them in. I'll remember that. And we are working towards a text test next Thursday on the whole unit. You now have learned all the sections. So it's 2.1 to 2.4. There's nothing new to learn in the section. There's 2 different review sheets we're going to be working on between now and then. So right now for this week, what you're looking at is this section 2.4, due tomorrow 1 to 11. Questions for me? All right. If you have any questions, just shoot me an email.